Welcome back. In this video, we will be picking up where we left off um, for the deck of cards project from the last video where we saved the deck to a file. This time we will be reading the deck back from a file into our program, and then we will also write two functions, one to deal cards at the deck and one to shuffle the deck. So I'm going to open up Visual Studio Code and open up the deck.go file we have. So here it is. If you don't have this file anymore, it will be in the GitHub repo in the description of the video. So no PowerPoint slides again for this video because it's not really needed. So let's get started here. So now we have this function here called save to file. Let's write a new function. I'll write it right under this one, and we'll call it new deck from file. And I'm not going to make it a receiver function because it's returning a deck. So it doesn't make sense. So I'm going to call it new deck from file. New deck from file. And then we're going to give it a parameter here. I'm just going to call it the file name. So it'll get the cards from the passed in file name. And it's going to be a string type. And it will return a deck type. Because that's what we want to get from this function here. We want to get a deck from the red file. So now we will do, okay, let's just leave it like this for now, because let's take a look at the Go package documentation for how to read data from a file. So we looked at the write file last time, so now we're going to look at the read file. So I already have it here. So if you take yourself to the Go package documentation here, and then we go to IOUtil. And then last time we looked at the write file, so now we need to go to read file. So click this. And as you can see, this function requires one parameter, a file name, and it returns a byte slice and an error. So let's use this function here in our new deck from file function here. So we'll do bs, comma, err equals IOUtil dot read from file, or read file, pass in the file name, and then we'll just leave it at that for now. So since this function returns two variables here, the byte slice and error, the byte slice returned will be assigned to this variable here, bs for byte slice, and then the second thing returned here, the error, will be placed into this err variable. And then we will just return the byte slice, but I mean, we're not returning the byte slice, but we got to change that byte slice into a deck, because that's what we're returning. We're returning a deck here in this function. So we have to cast this to a deck. So remember, deck type is pretty much a string slice. So we just need to use the split function in the strings package. So strings.split, and then we'll cast the byte slice to a string. Oh, this should be out here, and then here. So save that quick here. Errors declared not used. That's fine. Since we're not using that right now, I'll just leave it as that underscore. Okay, so what I did here was, since this function returns a byte slice, I took that returned byte slice and I converted it to a string. Or first, I used the split function from the strings package. If you don't know what the split function does, we'll take a look at it. So what it does is it splits it splits a split size to all. Okay, so yeah, it'll take a string and cut the string up into a string slice. And so I'll take a whole string, because our deck is saved into a file, and we're reading it back as a byte slice. So we're taking that byte slice and we're converting that whole byte slice into one big string. So then we take that one big string and we separate each of the cards in that one big string into a string slice. And our separator here is the comma. SEP here, this parameter, I'm using the comma. That's why I separate each card with a comma when I save it to the file. So then when we read it back, I can separate it using this comma. So to reiterate what I just said, since the read file function returns the text inside our file as a byte slice, I take our byte slice and I turn it into one big string. I then take the one big string and turn it into a string slice, and it knows to separate each entry in the string slice by the comma. So that's what I'm doing. And then since a dec type is pretty much a string slice, I can just do this cast here. And then it returns that. So that's the new dec from file function. And we'll run it here actually to make sure that it worked. So let's see here. Create a new variable called new dec, and then we'll assign it the dec return from our new dec from file function. And then if you remember from the last video, we saved our dec into a file called test file. So this is the file name we're going to pass in here. And then I will print our new dec to verify that all the cards are there that were in the file using our print function that we wrote here. So I'll save all of that, and I'll use the terminal here. Make sure you're in the right directory. Go run dec.go, and as you can see, it is exactly the same as this up here. The first print here is the original dec before we saved to the file. So this is what we saved to the file, and then this down here is the print of the dec that we read back from the file. So as you can see, they're exactly the same. So no issues there. So that's how we read the dec back from the file. Simple enough. And now let's write our function to shuffle the dec. So this is one's going to be a receiver function because it makes sense to do that here. I'm just going to call the function shuffle, no parameters. And so the logic here, we need to figure out a logic on how to shuffle this dec fairly. So there's multiple ways you could do this, and this is how I am going to do it for this video. We will be using a random number generator within Go. We will loop through the number of cards in our deck, and every time or every iteration, we will generate a random number from 0 to the length of our deck minus 1, and then we'll swap the value of the current card in the loop iteration with the card at the index of the randomly generated number. So to do this, we need to use the random number generator function in Go. So let's take a look at that in the Go packages. So if you navigate back to the packages, all the packages here, it will be under math rand. And we will be using the function right here, int in. So this int in function returns an integer that is non-negative pseudo-random number from 0 to n. n being what we pass here in our function call, from the default source. Now, if you don't know what a pseudo-random number is, it's pretty much, it's not really a random number. There's a certain certainty of what you're getting back. And the random number is generated based off of a source here, which is based off of a seed. So that means every time you run this, you pretty much will always get the same set of random numbers back. And that's not what we want, because we want to be always random. We want full randomness here. So what we need to do is change this default source to seed to our own custom seed here. And to do that, actually, if you go to the top here, it even mentions that random numbers are generated by a source, and they use a default shared source. So we need to use the seed function to initialize the default source if different behavior is required. And we want different behavior every time we run it because we want non-pseudo random numbers here. So we need to make our own seed. So what I'm going to use as the seed here is our computer time, because the clock on our computer is always changing. So that means the seed is always changing. So that means our set of random numbers being generated will always be random. So to do that, we first need to make a new source. To do that, we need to use the new source function. And if you look here, there's a new source function right here. New source returns a new pseudo-random source seeded with the given value. Unlike the default source used by top-level functions, this source is not safe, blah blah, which makes sense because we're using our own custom stuff, so there's no guarantee, but it's fine in case we're not doing anything crazy here. So we need to use this function here. And this function takes a seed and returns a source. And this source is what's being used to generate our random numbers. And since the source will always be changing because our seed is always changing, our pseudo-random numbers will always be different. So to do that, let's first create our source here by using this new source function. So back into here. So I'll create a new variable called source, and I'll assign it the source returned from the function new source. So ren.newSource. And to pass in the time of your clock of your computer, you use the now function in the time package. So time.now, and then I'm going to convert it into nanoseconds. So you do time.now.unix nano. So I'm using the new source function in the RAM package. I'm passing in the time of our computer right now in nanoseconds here. So this will give us a source that we can use. And every time the source, every time we call our deque function, it will generate a new source because the clock time will be different. So that means our seed will be different and our pseudo-random numbers will be different. So now that we have that, we'll make a new variable called r, and then we need to create a new random variable with our new custom source, because right now it's using the default source. So we need to create a new random variable that uses our custom source here. And to do that, we need to use the new function in the RAM package. If you search for new, you can see that, oh, there's a lot of instances of new here. Oh, right here. Function new, it takes a source, which we just have right here, and it will return a new rand type. See, new returns a new rand that uses random values from source to generate other random numbers. So we'll do rand.new and pass in our source that we created. And now we can use this and get different random numbers every time we run our shuffle function. And as I said, our algorithm earlier was to loop through our whole deque. So do for I range of D, and then at each iteration, we'll swap the card at index I with the card at the randomly generated index. So I'll call the randomly generated index new position, and we're going to give that the value returned from the random number generated from the function int n from the random package. So we do r.int n, and then we pass in our max number here, so from 0 to n. And our n is going to be the length of our deque, -1. So now we have a new position here. So now we just do the swap here. So the card at iteration I. Oh, by the way, to do a swap in Go, it's actually one line. This is a one line instead of having to do temps or variables or that other one where you don't want to use a temp but still have 3 lines. This is a one line. If you're from Python, they probably, I think this is the exact same way. So the card at D at I and the card at D at new position equals D at new position, comma, D at I. So what happens here is D at I will be replaced with the card at D at new position, and D at new position will be replaced with the card at D at I. So that's it. That's all we have to do for the shuffle function here. And to show that that works, we will shuffle our deck here, new deck dot shuffle, and then print it. So let's check it out. So I should probably add a line. It would make it easier to look at. 1 second. fnt dot print line. Okay, let's try this again. Okay, so this is the original deck, and then this is the deck that was shuffled. As you can see, the card they're not in the same order anymore. So looks like our shuffle function works properly. So that's good. And the last thing we're going to do is write a function to deal cards out of the deck. So let's do that. Make a new function called deal. It'll take a deck as a parameter, and then we'll take an integer parameter called hand size. And then we'll return 2 decks. One deck being the deck of cards after the cards are dealt, and the other deck being the cards that were dealt. So this is simple. All we're going to have to do is write one line, return the deck from the beginning to hand size, so from the top of the deck to the hand size, and then return from hand size to the end of the deck, which is what's left over. Simple enough. One line function, and then we'll test it here. So creates new deck. So all right, so we're going to need 2 variables here. So I'll call this one current deck, and then I'll call, wait no, so the first one return is the cards on top of the deck. So we'll call it hand cards, and then the other one will be current deck, or rest of deck. Let's just call it rest of deck. And then, so I just need to call this function here, deal, and we'll pass in our deck, and the hand size, we'll just say each hand has 7 cards. So save that, and then we will print the hand card, the 7 cards that were dealt to us in the hand cards variable, and then we'll print the rest of the deck. So hand cards dot print. If you're wondering why there's red squiggly, it's because we're not using the variables. Rest of deck dot print. It should be a lowercase p here. Save that, and then let's call it. Actually, let me add a space here again. fmt.println. So let's do that, and that does not come out nicely, or did it? Rest of deck deal hand cards dot print and rest of. Let's see. So this is the trying to figure out what exactly got printed here. Right from file. I feel like this got bunched up somewhere. Hold on, let me clear this really quick and run that again. Oh, I see what happened. It's stuck on the okay, I see what happened. It's printing out under the other prints. Okay. There we go. So this is the deck that was shuffled. These are the 7 cards that were drawn to you. As you can see, if you match it up here, it is. And then this is the rest of the deck. So, figure that out. Anyway, yeah, so in this video, we read the deck back from a file into a variable in our code, and then we wrote 2 functions, one to deal cards out of the deck and one to shuffle our deck. And for the shuffling, we had to use the rand package and make a new seed. So that was good learning experience. So that means in the next video, we will talk about error handling. So thanks for watching, and I'll see you in the next video.